A recent article on Martin Fowler's blog talks about what is code in the conditions of the new AI large language models usage for generating code, and asks questions about, do we actually need code, or which part of code do we actually need? What does code represent? And so it's very interesting to me to go through this article and comment it out and see, add my own observations and my own commentary, so that maybe we can learn a little bit more about what code actually is. Welcome back to Think Design Work Smart. I'm Alex Bulbak and I'm coming at you from the Mosaic Work Studios. And today I want to talk about what is beauty. I find myself caught between the Kantian intersubjectivity idea of beauty, the evolutionary account on beauty, and the relational theory, because I believe that beauty is partly about some characteristics that you can define that are inherent to an object, but also about what you feel about that, and the feelings that you have about beauty are probably shaped by society and by evolution. So, I think we are not talking about that. We are instead talking about what is code. So code, this is the article that I'm talking about. It's on martinfowler.com, published on 12 May 2026, written by Unmesh Joshi. Unmesh is a distinguished engineer at ThoughtWorks based in Pune, India. He's the author of Patterns of Distributed Systems, which is a very good book. And we are going to go through this, but before we go through the article, let me introduce a little bit what are my thoughts about code. You can look at code in its textual form. So code is fundamentally text, and then it serves all the functions that text serves. It's a communication medium, but what makes it interesting is that it's meant to be a two-way communication medium, or for two different types of, and very different types of audience. Code is text, a communication medium for the machine, and the communication medium for the programmers who are coming, reading, modifying, in order to introduce new features, fix bugs, understand what's going on in the system. And because of this, you have one characteristic of code, which is it needs to be extremely precise. The languages that we built with code are similar with the natural language, but they are much more precise and therefore much more limited in what you can do. There are certain things that need to be very clear, very fixed, and that's the syntax and the semantics of the code. However, what I think most people don't realize, or most programmers don't realize, is we still have a lot of leeway in how we structure code because we can give names. Names are the really powerful thing that is left in the code. So another way you can look at code is that it's a combination of names, which are given by programmers, and fixed structures that mean very specific things. Those fixed structures actually have two characteristics. They have a text and a meta text characteristic. The text characteristic of code is what you read, like the operators that you use, the logical operations, the arithmetic operations. But there's also a lot of meta text, which is given by the structure of the code, empty lines, functions that are, if you have a functionality in your product, why is it split in a certain way? That is meta text. So code is actually surprisingly complex, even though it might seem as the simplest, most constrained form of communication that we have. It turns out that we are actually playing on some things that are not played on that much in the real world, in the natural language, but they are played more in a constrained language, like a programming language. And because of that, what we have is, which is arguably the most advanced, successful way of organizing programs right now, is based on one hand on structures, but on the other hand on an ubiquitous language, domain-driven design, right? What is it about? It's about defining terms that are specific to the domain, using those terms everywhere in your code. And that actually has a very high similarity with something else that exists in natural languages, which is called a jargon. A jargon is a restricted language that only people from a certain domain understand. So basically what domain-driven design is doing is building upon the linguistics of the jargon and mixing it with the constraints of programming languages, and you get something that creates a rich set of building blocks that you can use to build any kind of product or products in a specific domain. But now enter large language models. What can large language models do with this? Well, first of all, large language models are still language. This is interesting, right? So large language models are still using language and language building blocks. This is one of the reasons they can work with code. It's also one of the reasons why they fail working with code after a certain size. And the reason is certain connections inside the code are much more difficult to grasp and to keep in a context memory that's based on statistics than it is for people. We are able to keep those things in mind somehow, or those connections. Maybe it's intuition, maybe it's training. I have no idea. We don't yet know what's going on there. But something seems to happen in the human brain that is different from what's happening in the large language models. So when I think about what is code, I think about all these things. There is a whole semiotics of it, like how do you transfer meaning between people just with this very constrained language? Very interesting, because part of it is what you write, the textual description, part of it is the meta text, the structure, the empty lines that you leave, the extraneous things that you add, like documentation, comments. Well, you could say tests, although for me tests are part of the system. They are also code. So code is much more complex than it seems. And to add to this, you have another aspect, which is how does code evolve? Because code evolves very differently from other systems. Here's something that I noticed about code. So you might have pieces of code that get to a point of maturity. What my metaphor for this is cooking, right? So the ideas get cooked and they get to a point where they are ready, they are done, and they are well described in the code. There's not much you can do. They are working properly inside the code. And those areas tend to remain steady and fixed. And so you have parts of the code that you don't need to change. You have parts of the code that need to change because on one hand, the ideas didn't cooked enough. And on the other hand, the world around your code is changing. And I think these are the two main reasons why change happens. And then there's this phenomenon happening with code when it gets rigid. So you want to change it, but it got so rigid somehow. Even though in theory code is soft, code is malleable, you can change it, you can restructure it. But parts of the code become so rigid that you are very afraid of going there and actually untangling the mess. And there's no good metaphor to describe everything that I've talked about. So code is pretty much its own thing. We keep trying to compare it with other things, but it doesn't work. It doesn't work to compare with construction, because materials for construction are completely different from code. It doesn't work to compare it to gardening, like I've heard. It's very much its own thing. And now, these used to be very philosophical questions, right? Not many people would think about those. But now, given that we have this new client, creator, partner in shaping the code, things are becoming important. So let's look at the article. What is code? At a high level, the answer to this question seems obvious. Code is what developers write. Instruction is expressed in a programming language that tells machines what to do. For years, writing code meant typing it out word by word. Progress is measured by how efficiently code can be produced, compiled, tested, and deployed. With modern LLMs, we no longer need to type every word to produce code. Large amounts of executable code can now be generated from high-level descriptions. This forces a deeper question. If producing code becomes cheaper, what remains valuable about code? Two aspects of code. Code has always served two distinct but intertwined purposes. First, code is a set of instructions to a machine. It directs computation, moves data, interacts with storage, and coordinates execution. In the era of LLMs, this is the part being commoditized, right? So this is what I meant. There are two ways in which code communicates. One is code communicates to a machine, and this needs to be very precise. The other one is code communicates to developers. Now, interestingly, I think he's mixing, we'll see in a moment, because I think he's mixing a few things together that are, you could see them as separate, but let's see. Second, code is a conceptual model of the problem domain. This is the design aspect. A well-designed code base does not only contain instructions for the machine, it also contains concepts for humans and tools to reason with, right? So what he's calling conceptual model, this is what contains what I was talking about. It contains the text, the names, it contains the meta text, the semiotic aspects. It also contains the structure. But it's also interesting that it says it gives humans tools to reason with. So tools, this could be tools that we create also with large language model in order to explore our code. The activity we call coding is where these two aspects meet. We are shaping the concepts, names, boundaries, and relationships through which the system is understood. Okay, so this is a pretty structural way of looking at code, and fair enough, that works. Conceptual models and vocabulary. Making the conceptual model explicit is the deeper aspect of coding, driven by the domain and the use cases the system is meant to address. Every domain comes with established processes, practices, and more importantly, a shared vocabulary. That vocabulary, as well as the conceptual model, becomes visible. The jargon. We already covered that. Vocabulary is usually understood as the set of words used in a particular language or subject. I'm able to write this article because I know the vocabulary of English. The reader can read it because they share their vocabulary with me. But to understand this article, knowing English alone is not enough. This article is about software development. Software development is a broad, mature field with its own technical vocabulary. When I use a word like abstraction, I'm not merely using an English word, I'm referring to a specific software development concept with its own meaning, history, and implications. A reader unfamiliar with software development may understand the word at the surface level, but misses deeper meaning in this context. The mature areas with their own established vocabulary are called domains. And what he is describing is a jargon. So a jargon is a specific subset, or actually it's more than that, it's more like a specific sub-language. Even if you use English to express a jargon, you are using the jargon of software development, which means that you may use certain words from English whose base context, whose base meaning in English is different from the meaning that you use within that domain. So, yeah, we're talking linguistics here. It's fun. This is true of all serious domains. Communication depends on shared vocabulary. Whether we are communicating with a person, a framework, or an LLM, the words we use must map to concepts that the receivers can understand and act upon. We're going to become linguists, friends. It's really what we need to become. Vocabulary in code. A well-designed code base is a representation of a certain vocabulary. Where does this vocabulary in code come from? This is where the unique nature of software development truly shines. Software development works on the intersection of various domains. At one end, we have domains like banking, finance, retail, inventory, healthcare, insurance. On the other, we have domains like web infrastructure, AI, data engineering. Someone doing web development needs to have a strong grasp of web architecture, semantics of web methods, universal caching potential of GET, and the implications of those semantics. Someone who does not know what that will not architect complex systems well. The same is true in other domains. Vocabulary is not just a collection of labels. It carries meaning, constraints, and design consequences. Yeah, it's a jargon. And indeed, what makes software development different is that we are actually using two jargons. We need to use the jargon of the domain up to a certain point, and then use the technical jargon from a certain point forward. Now, this is true to some point of every engineering. It's one way, if you want to build a bridge, you'll talk about the bridge in a certain way with the people, with the city who wants to build that bridge, and you'll talk about it completely different with the construction team. It's common. The difference, though, is that for us, the mapping is stronger. The concepts that you used to discuss with the users, with your domain experts, are the same concepts that you need to place in code. And you have more flexibility in including those concepts in code. And by the way, important thing, when you're doing domain-driven design, you're not modeling a real-world domain. You are modeling a domain projected upon the technical stuff. So you don't use the real-world concepts, you use the concepts that make sense within the technical part of your product, but that kind of map with the concepts that people are using when talking about that. So it's all really a language game, right? Because the real world thing, like let's say you're doing software for managing an oil rig, you might have an oil pipe and you might have sensors on the pipe and stuff like that. You are not using the real pipe in your code. And when you talk about it, what you're using is concepts. And so you have the real pipe, then you have the concept of the pipe that you use in communication between the domain people, the engineers who manage the oil rig. But then you extract the pipe concept that you use within your software, which maps to the word but not to the real world concept. So it's really a language game. It's tough to understand, but that's really what we are doing. If you take away the communication with the computer, what you are left with is something that resembles linguistics more than mathematics, let's say. Consider retail domain. When we write code for retail, we talk about customers, products, orders, shipments, payments. When we are doing web development for the retail domain, the code contains concepts that map retail domain to web domain. For example, catalog is a resource, and we can use get, post, put, delete, HTTP methods to perform operations on it. Someone writing code needs to be familiar with both the vocabularies. Coding for a domain is fundamentally an act of translation. That's exactly what he's saying. The developer maps the domain vocabulary on the vocabulary of technical domains. In doing so, a new vocabulary is also built using the constructs provided by a programming language. There are concepts like logs, repositories, quorums, transactions, and specific concepts like money. Concepts become types, relationships become interfaces or contracts. Rules become invariants, and workflows become compositions. Okay, roughly, okay. I don't fully agree, but roughly he's right. And no reason to go into a ton of detail on this. So we'll agree with this view at a high level of granularity. If you zoom in, it's not exactly that, but it's good enough. The precise names of variables, the boundaries of methods, and the hierarchy of classes are discovered step by step. The right abstraction often is not obvious up front. It reveals itself only as you continuously mold and refactor the code against real-world constraints. This is what I meant. You need to let the ideas cook, and they cook in time. And when they get cooked, they eventually stop requiring change. Only this is a function of the outside world as much as the function of software. Yeah, it's a very interesting point. The right abstraction often is not obvious upfront. It reveals itself only as you continuously mold and refactor the code against real-world constraints. When used well, the code slowly becomes a readable, highly specific representation of the domain itself. And representation is a very important thing here. It's not the domain, it's a representation of the domain. For the technical domains, we typically find frameworks and libraries provide the base implementation patterns. Frameworks and libraries are codified vocabularies. And by the way, the same happens with domains that you work with. They are codified vocabularies. If you work with retail or real estate or engineering, or they have their own vocabulary, and that's one of the reasons why it's so valuable to use the same vocabulary, because that one has already been time tested. People have used it, have evolved it. Their jargon is mature because it took a long time to get there. And instead of starting from scratch, you start from a mature jargon that you can then adapt to a representation of that jargon within your software. That is why ecosystems such as the Spring framework exist for building enterprise applications involving the web integration and related concepts. Bound in context and local vocabularies. Frameworks work well when the domain has stable recurring structures with broadly shared semantics, but something like online retail or stock exchange is different. These are not just technical stack. The main reason there is no universal high-level framework is that the vocabulary is not stable enough across all instances of the domain. And that's a function of natural language. Pretty much like we have a lot of different programming languages, why would we invent other programming languages? We don't actually need as many programming languages as we have, but we had. And that is a culture, a function of culture. And this is exactly why you have different or competing jargons within a larger domain, right? It's basically the same cultural phenomenon. There are competing schools of thought. Some people think that expressing things in a certain way gives better results, or they understand it better, or they can communicate better. Same as for programming languages. So yeah, programmers are more human than you think. The attempt to find universal abstractions becomes either too generic to be useful or too opinionated to be widely applicable. The closer you get to the core business model, the more the abstractions must be discovered locally. This is why the idea of bounded context in domain-driven design is so important. The bounded context marks the boundary within which a particular vocabulary model are valid. The same word may mean different things in different contexts, and each context needs its own abstraction rules and language. I like to give the example in online commerce, in web commerce. So you have the notion of a product that lives across multiple bounded contexts. You have the notion of the product as it's presented on the web page. Is that the product? No, that's not the product. That's a representation of the product, presumably a marketing representation of the product. You have picture, you have characteristics, you have pricing, you have offers, you have feedback from users. All of this is marketing stuff. Then once somebody adds the product to a shopping cart and makes an order, the product turns into a line item in an order, which can in turn transforms into a line item in an invoice. But it also, in the context of accounting, a product is something that you have a number of and you sold one for a certain amount, and so you get that amount of money. But then you have the notion of a product as it is in the warehouse, where somebody needs to know where that specific physical product is located in the warehouse so that they can go. When they receive the order, they go, pick it up, pack it in a box, and prepare the box for shipping. And in the shipment context, you basically have no product. What you have is a box. And okay, that box contains a product, but that's not something that the shipping company necessarily needs to know. They need to know certain characteristics, like is it fragile, so on. And so they ship the box to the end consumer, who opens the box and gets the real product. But you see how the name product represents at least 4 or 5 different things in the different bounded context. How do we build these local abstractions and vocabulary? A lot of this vocabulary is built through iterative sessions where we write code and reflect on it. Techniques like TDD are excellent for this iterative development of the vocabulary. Yes, this is one of the things that people miss about TDD, particularly if you don't practice TDD. Part of the refactoring step of TDD is improving names and removing duplication. And improving names is basically refining the jargon in your code. And that's since names are part of what we use to communicate with other developers and with large language models now, that is very important. They help us discover the right names, the right abstractions, and the right boundaries by forcing continuous feedback between the model and its behavior. Coding cannot happen in isolation. There must be close collaboration between domain experts, users, and developers. This collaboration is necessary to build these local abstractions and vocabulary. This connects directly to the lessons of agile software development, the emphasis of individualizing interactions, customer collaboration, working software, and responding to changes, not just process advice. It is a way of discovering and refining vocabulary through feedback. Yeah. Only many people took this as meaning that you need to have a sprint of exactly 2 weeks and a precise structure for the team and so on. And that's not necessarily what it is. It has some deeper meaning. Domain-driven design makes this more explicit through the idea of a ubiquitous language, a shared language developed by developers and domain experts and tested continuously against working software. Jargon. Programming languages are thinking tools. Building vocabulary through code requires active engagement in writing and reshaping code, not just passive review of generated code. Yes. The very act of thinking deeply about code often happens only when we are actively engaged in writing it. Well, I would argue that you can actually do it with a large language model as well. You don't necessarily need to write the code, but you do need to converse around the code. So maybe that's the problem. What we need is the conversation, not necessarily the act of writing. But the conversation is extremely important. And since most programmers were running away from these conversations and were just writing code, of course, now things are much more difficult because they turn into conversation. And you don't have this skill. You don't have this muscle developed. And you need to develop it. But let's see what else he's saying. So I kind of disagree with this, but maybe he has a deeper point. Programming languages and their constructs and constraints themselves become thinking tools. The design constraints provided by different programming languages help shape our thinking. The channels and lightweight threads of Go, the object-oriented models of Java, or the ownership modes of Rust all push us to see structure boundaries and trade-offs in particular ways. In that sense, programming languages do not just help us express a design, that they also help us discover it. Maybe, but it's another application of the medium is the message. You have certain constraints in your programming language, you'll get certain messages. Is that really the design? Well, it will be a different design in a different set of constraints. So to me, the act of designing is more interesting than the design itself. Let's put it that way. Which means that for me, the actual programming language that I use is just a tool. And the advantages of using a programming language plus a large language model means that I can make the most out of tools at my disposal. Let's see an example. I recently had to design a custom feature implementation for the asynchronous programming examples. One of the important aspects of future API is to design the compositions to be able to express a sequence of action. Our feature is called action 1, feature 1 then compose, val 1 to action 2 of val 1, then compose val 2 to action 3 of val 2. Knowing the concepts of vocabulary of functional programming is crucial to be able to implement this API well. Not knowing those concepts results in awkward implementation of usage. Right, but you could explore this if you ask the right questions to your agent. Because one thing I do with the assistants is I ask for alternative ways of doing one thing, and we always start from outside in, from the interface. Okay, not always. Sometimes we discuss the internals because maybe we have certain technologies that we can put together in order to generate something bigger. But yeah, often we start from the interface and we discuss on the interface until we get to a point where I'm happy with it, where I've seen 3 options, 2-3 options, and picked one. Sometimes the programming language syntax can become too verbose, hide the underlying structure of the solution. For example, recently while working with a snapshot isolation implementation from my workshop, describing the essential requirements in plain English was a bit vague. Putting it in Java code was too verbose. More constrained formal specifications like TLA+, I have no idea what that is, would have helped. But even writing a single page pseudo-formal spec helped significantly. Yeah, okay. This pseudo-formal spec helped clarify my thinking and served as a good basis for further discussion, implementation, validations through test. Working with LLMs, considering coding as vocabulary building has important implications for LLMs. LLMs are trained on vocabulary from a large body of text and code. They learn recurring relationships between names, APIs, libraries, frameworks, idioms, design patterns, and implementation structures. When they see words such as control, repository, reducer, consensus modules, or transaction log, those names are not just labels. They carry associations with known constructors and expected behavior. This is why vocabulary matters when working with LLMs. Yeah, they're absolutely correct, yes. And you need to create a jargon to work with LLM. By the way, you can also train your agent, train your assistant through interactions, through examples, through skills, through settings files. And that builds a vocabulary and a set of desired interactions that you can reuse. This is why vocabulary matters when working with LLMs. If our prompts use vague or inconsistent language, the model has to guess the design we intend. If our code base uses unclear names and inconsistent concepts, the model has little stable structure to follow, but when the vocabulary is precise, consistent, and embodied in the code, the LLM can map our intent more reliably to useful implementation. More reliably is correct. It still has limitations. Part of the limitations are that they don't see the meta text and you need to provide it somehow. And part of the limitations are the context window limitations. And my feeling, my intuition is that we'll also get to fundamental limitations on the line with Gödel's theorems and with halting problem and things like that. I think that will hit some fundamental limit at some point. But yeah, up to a point, yes. Cognitive debt. This also explains the particular dangers of LLM-assisted coding. Cognitive debt. Cognitive debt accumulates when words, abstractions, and structures are used without their meaning being well understood by the people working with them. LLMs amplify this risk because they can generate large amount of plausible code very quickly. The generated code may contain controllers, repositories, reducers, factories, transaction schedulers, and other familiar-looking structures. The code may compile and may even pass basic tests. But if the team does not understand the conceptual model behind those structures, the code base has gained vocabulary without shared understanding. The problem is not that the LLM generated code. The problem is that the code introduced vocabulary faster than the developers build understanding. That gap is one of the major contributors to cognitive debt. Now, you see, this is part of it, I think, although you can drive it to get to the point where it doesn't do that, right? You can have skills, you can structure it, you can put constraints. But let's assume that you do generate a bunch of code. Do you care as long as it works? I'm not being facetious. The thing is, we are so focused on thinking in syntax and not as focused as thinking in features. So let me ask you this. What if you had small modules that are well tested, that you don't understand necessarily how they work inside, but they are proven to work and they do work. And instead of modifying them, or actually you could modify them or you could rebuild them when you need to add new features. Would that be such a big problem? Do we really need to understand everything that is in code? Or do we just need to make sure that it works and that it does what it's supposed to do and that the whole system works well together? It's an open question. I mean, I don't know. On one hand, I like understanding and reading code and changing code. But on the other hand, the pragmatic way of dealing with this could be just to work on very small modules, self-contained, forget about duplication between modules, we don't care. And if something doesn't work, okay, we rebuild it. If we need to add something new, we add it on the side. Would that be such a big problem? Maybe, I don't know. Maybe there could be some connections that are not properly found between these different modules. But I don't know, maybe. Let's go to the next section. Code does a shared conceptual model. As we discussed in designing abstractions with LLMs, writing code has two deeply interwoven activities, discovering and applying abstractions. Discovering the abstractions is where we are developing the vocabulary. Once a strong vocabulary is built, it represents the shared conceptual model. Once that model exists, much of coding becomes using that conceptual model to build use cases. This is where good libraries and good foundational code shine. This is the part where we try to hide the intricacies of the programming language and environments and give a more and more English-like interface to the vocabulary we have built. A typical way this works is to build a DSL to make using this vocabulary or these abstractions easy and close to natural language. LLMs are excellent at this. They provide a natural language interface to your abstraction vocabulary. The best part is that if you have executable code behind your vocabulary of abstraction, it itself acts as an excellent guardian for the LLM to fix mistakes. Good abstractions, executable behaviors, test types, and invariants all help constrain the model and make itself more useful. We can use the vocabulary to build an external DSLs. LLMs work very nicely as a natural language interface on top of this external DSL. I have been using LLMs to great success with tools like PlentyML, and it's not a surprise since LLMs by design were best to map vocabulary. In that sense, strong foundational code becomes even more important in the age of LLMs. Once the vocabulary of the system is well formed, coding becomes less about producing raw syntax and more about using a well-developed conceptual language to build reliable software. Yeah, so that's another thing that I keep thinking about. What if we could build tools that put together solve families of problems for our customers instead of building one single application for one single very specific problem? And that would make a lot more sense in this context. Code itself has harness and context. A lot of discussion on context engineering and harness engineering treats code as black box with the responsibility of it to be generated correctly, managed externally by providing right context in prompts or constructing right harness with specs, tests, static validations to make sure its structures and work as intended. A well-structured code with abstractions forming a well-defined vocabulary itself acts as the most important part of the harness and context. I have repeatedly seen good success with well-designed code working very well with the LLMs. More importantly, when the code is built with stable abstractions with clear semantics, you get some freedom to choose whatever LLM model you use, and you do not need to worry about how accurate your prompts are. Code structure and accompanying tests themselves provide context and harness that makes the LLM's output reliable and useful. Yes, so basically if you build the right model, everything else falls in line. But this still doesn't solve the problem of building the right model, although I would argue that that is more design than writing the code. The design effort should be in figuring out what the model is, and you can do that by conversations between people, conversations with the large language model, and prototypes that showcase the results of those conversations and that you recreate or evolve as time moves on. And so this brings us much more in line with what design is really about in every other discipline. That's precisely what it is. And if you are interested in figuring out things like that, look at all the different types of chairs that exist, that were designed. Why do we have so many types of chairs? Well, because each of those you're basically using the same building blocks. You still need something to sit on. You need the chair to be in an equilibrium. And then based on those, you still have a ton of different combinations and ways of structuring chairs. And which one is best depends on context. That's precisely what we're doing now with this design approach that he's describing. Conclusion: the role of coding is not disappearing, but it is changing. As LLMs make code generation cheaper, the mechanical act of writing instructions becomes less central. What becomes more important is making the conceptual model explicit, discovering the right vocabulary, and refining the vocabulary through iteration, domain expertise, and feedback. Conversations. This is also why programming languages continue to matter deeply. Maybe. I'm not sure. For now, yes. But I'm not sure. We are not meant to be passive reviewers of generating code. The act of writing code is itself part of our thinking. Is it though? I mean, the act of writing is part of our thinking. But, okay. So there are various ways of thinking, and they are all pretty good, right? No, we have a full video on people who think by talking and people who need So people who need to talk in order to think, and people who need to think in order to talk. And my feeling is what he's describing is people who need to think in order to talk, but there's the other approach, which is talking as thinking, and this is something you can do by conversing with your large language model assistant, right? Interesting perspective. Code is still instructions for a machine, but it is also a model of understanding. In the LLM era, the second role becomes even more important. The future of coding is not just writing more code faster, it is building better conceptual models, better vocabularies, and better foundations on top of which both humans and LLMs can work. And I guess my point here is really code as we have it now the building medium for those models, or will we need something else? And how would that something else look like? If you have any answers, or if you find this question interesting, let us know in the comments and we can keep continuing to explore it. In the meantime, thank you so much for your support. We are closing very quickly to 1,000 subscribers, which I hope will get through pretty soon. And if you let your friends know, if you let your colleagues know that we are discussing about deep topics related to large language models and how to use them in code, we might have a chance to get there sooner. So thank you for your support. Thank you kindly for the view. And until next time, remember to think, design, and work smart. See you next Saturday. Bye bye.